All right, so PHP Anti-Patterns. So as long as I'm giving this talk at PHP World in about a month, so you're getting beta content. I finished these slides about an hour and a half ago. Finished the outline a while ago, so we'll see how it goes. And at the end, when you're asking questions, if you also think it sucks or have suggestions, I'll take those as well. So about me, my name is Josh Butts. I'm the Director of Engineering at Offers.com. I've been getting paid to write PHP for over 10 years. Doing it for free for a little while before that. Been an organizer of Austin PHP for ages, since the second time I showed up at one. Right place, wrong time sort of thing. I taught classes in PHP and I play competitive skee ball. Got my first perfect score on a round this week, so that's pretty good. Wow. You can find me as JimboJSB pretty much anywhere, but mostly GitHub and Twitter, I would imagine, is what you're interested in. I also do idle in the Austin PHP IRC channel. Oh, Logan forgot to mention that. So, how many of you guys are less than 5 years experience with PHP? About half, cool, that's perfect. How many of you are writing object-oriented PHP regularly? Basically the same people, so that's cool. So this can be good for you. So let's talk about anti-patterns. So what is an anti-pattern? This is copied directly from Wikipedia. So basically it's a common response to a problem, and it's usually the wrong one. So a lot of times as you are programming, you sit down and you think about something and you're like, oh, I know how to do this. We need to do this, this, and this, and you start typing, and 45 minutes goes by, and you've got what you think is like the perfect solution ever. And because you should have really sat down and thought about it for maybe like 20 more minutes before you started. Because what you might have come up with is an anti-pattern, which is something where you oftentimes find yourself doing this, and you don't even realize you're doing it, and it works great when you first write it, and then it will fail you later. So in actuality, it's always a bad idea. So you tend to see this in object-oriented programming. In PHP, I would say most of my examples are going to be object-oriented, but there's a whole other litany of them we could talk about that are just in PHP, the language, and how you should not use that. And I wanted to not come off too preachy and ranty, so we're going to stick to actual patterns that you could go Google and find other examples of. These tend to kind of be on the opposite side of a good object-oriented design pattern. There's books and books and books about that. We're not going to get into that here because this is about all the bad stuff. So why does PHP let you do this? Well, PHP will let you do pretty much anything you damn well please, as long as it's not a syntax error, and it's dangerous in lots of different ways, and these are just one of them. Sometimes we'll look at this stuff and we'll be like, well, if that language feature just didn't exist, you wouldn't even be able to do this and it would be fine. The PHP isn't about safety. It's about giving you the stuff you need to get stuff done. Everybody's guilty of these. Across the board, I'll even call myself out on some of these because some of the stuff that I was really proud of when I wrote it, I sat down to write this, and I was like, damn. Now, I could link to my GitHub as the example of why you shouldn't do this. So the road to hell paved with good intentions, we've all heard that one before. Like I said, you may sit down and look at these and you think you've got the greatest idea in the world, and it may be actually a pretty decent idea, except for that giant but at the end of it that you haven't thought of yet. So it could be the lesser of some other bad choice. You could be stuck with business requirements that really need you to do X. And in order to get that done in an efficient amount of time, you just have to do something bad. And it could be that you have to pick one of these bad things to do, and instead of another one that's even worse. And you know what? That's reality. So, as I was kind of saying, good software design doesn't always make money. If you come up with the most elegantly designed job queuing system, that's worth exactly $0. And your people who run your business that you work at, or your clients, if you're doing freelance work, they don't really care whether you have bad code or anti-patterns all over your code. All they care is if it does the thing that they can then either sell or have customers use, and it actually makes money, right? So it could be you're in a scenario where not doing anti-patterns and having great software design just isn't even important. And that's fine too, but there will come a time when it will be important, because eventually it may not make you any money, but it will cost you money when you can't implement another feature, or your site is down, or it takes 10 times longer than it should to go refactor code. So in the end, we blame PHP for this. It's PHP's fault that you can do all these things, technically speaking. But so you really have to kind of educate yourself enough not to shoot yourself in the foot. Who's heard of not invented here syndrome? A couple people? So not invented here syndrome, everybody should write their own thing, right? There's 1,000 different database libraries on the internet. I'm gonna write my own because I want to. And I think it'll be fun. There's hundreds of different ways to do password hashing for your website. And I'm gonna sit down and I'm gonna bang one out, and I'm gonna write my own because that's how I want. I don't like the way that one works, and I don't like the way that one works, so I want to just have my own. That's not invented here, because there's plenty of other good stuff that's already out there that you could be using that is probably better than what you wrote. More people have looked at it, and it's been better tested than the thing you just wrote. You should really consider looking at what else is out there. This is not in itself an anti-pattern, but it can often lead to one. If we go back to what we said at the beginning, it could be a common response to a common poor response to a problem. So if your instinct is to go write your own, there's a good likelihood and you've never done it before, you may come up with that common poor response to the problem. Examples of this: Facebook and Laravel. Facebook is classic NIH. They write their own everything. Granted, Facebook has problems that no one else has. So they invent problems as well. Nobody else has the problem of storing, I don't know, tens of billions or however many pictures they have right now. So Facebook thought it'd be a good idea to write their own file system. Nobody else has the problem of literally 5% CPU savings on executing PHP scripts saves you millions of dollars a year in hardware costs. No one else has that problem but Facebook. And so Facebook thought they'd write their own version of PHP. You shouldn't write your own version of PHP. I'm going to go out and I'll even say that. So what I do think is that you should write your own X. You should write it. You should write it once, and then you should never use it. You should write it so that you understand all the pitfalls and all the complexity that goes into it, because you actually had to think through the thought process, and then you should go find someone else who's done it better than you. Writing your own is good because it gives you the perspective to evaluate the ones that are out there and pick one that will work for you. It may have to be 80% good enough or 90% good enough, but 90% good enough when it comes to a security library or like a crypto library. If it's 90% of what you need, in fact with crypto it's probably 100% of what you need. If it's 90% good enough but it has no bugs, that's really, really good. Because what you don't want is to accidentally, encrypt something that you can no longer decrypt, and now all the data's gone because you didn't really think of that one corner case. So one of the other problems with NIH is that you may be reinventing something that's already bad. Like you could be not invented hearing it, and it could be someone else has already done something bad as well, right? So like I really think that writing your own does give you the opportunity to go look at the source code for these libraries that you may pull in with Composer or download, God forbid, PHP classes or something. But you can look at them and see how they work and step through them with a debugger and say like, yes, I see now that I should have been doing this, or like my solution was very naive and this one is better. So let's talk about actual anti-patterns. I've got a handful here that we'll go through just to kind of evaluate. God objects. Objects that know too much or do too much. I'm going to focus mostly on objects that know too much. Objects that do too much, I don't think are too much of an issue. I've taught object-oriented PHP to people, and I haven't seen anybody have a real tendency to write objects that do too much. But objects that know too much are very, very tempting. Singletons. anything with statics in it, public statics, service locators to some extent. You're talking about these objects that can go out and they can grab at anything from any file. So you can get at the data these objects have from any place in any file. So if you're talking about writing PHP applications and you're talking about writing them in an MVC framework, God objects basically subvert the MVC framework. There's a separation of concerns. If you have God objects that float around in here, it lets you violate that separation of concerns whenever you want. Singletons are usually a good example of this because it means you can get at them from anywhere, and they're basically global state. The equivalent of, PHP has a history of this, of going back to pre-PHP 3. Everything is in global state. You just throw variables and files, and you include files here and files there, and things just all come together in this one mush of variables. Singletons, or things with public static properties on them, they end up being the same thing because you don't need an instance of it. You can get at it from anywhere after that file has been loaded, and the class exists as far as PHP is concerned. Service locators are very popular right now to do dependency injection with. I need a service locator for my database and for my view renderer and whatever else the framework might be using. But actually, these can get you to the place where you can get at your view renderer in places you shouldn't be able to, or you can get at your database in places you shouldn't be able to. So offers.com has been a Zen framework application since the day it launched. It's currently Zen Framework 1.12, whatever the latest version is. And one of the things I learned early on, Ralph was the one who convinced me to write it in Zen Framework, was that Zen Controller Front is really the solution to every problem in Zen Framework. Because this thing is the core request handler. Things come into your index.php, they basically get handed right off to this thing, and this is the thing that goes and dispatches all of Zen Framework. So it's a singleton. There can be only one of them, and it's got a get instance. So it basically gets you the one get instance on that. You can call that from anywhere, and it gets you the front controller. The problem is it has a reference to everything. I mean, literally everything. To the point where it actually has circular properties and references, so you can't actually var dump it without sometimes you get a seg fault. It's that deep of a recursive object graph that this thing has a handle on. So, things this lets you do. You can, in your view, decide to change the response code of the request you sent back, the response you sent back. So, in a HTML file with PHP in it that's a template, you can go and you can say Zen Controller Front, get instance, get request, set response code. In your view. That's not MVC. That might as well be spaghetti code. You disable exception handling from your models. You can say Zen Controller Front, get instance, get router set throw exceptions false, or something like that. Because you can call get instance on this thing anywhere in any piece of PHP across your entire application, and it has the request, it has the response, it has all of the helpers, it has the view, it has the router, it has the dispatcher. You can basically, from your view, decide that no, I'm not done dispatching, and go dispatch another request that didn't even happen. You can send it through one redirect from your view. You can have your data models go in and change the cookies that get sent back. All sorts of really dumb things that you shouldn't do if you actually believe that using an MVC framework was a good idea in the first place. On the downside, it's really, really convenient. There are places where you're like, you're using a framework, but you put your own code into the framework, and you don't use nobody uses a framework 100% out of the box. It changes nothing. Everybody's got their own objects, their own stuff that they're putting into it, and you find that one thing where it's just a ticket and it comes up to the top of your issue tracker, and you're like, how the hell am I going to do that? And Zen Controller Front can do it for you. No matter where you're at, PHP, in your project, you get a hold of that and you can change it. And so you can, the downside is this God object lets you get shit done. And so sometimes that's more important than actually caring about whether you're doing good things or not. My next biggest favorite one, database IPC. Your database is not a job queue. And this leaks in so quickly. Everybody's done this. I sat down to think about this when I was thinking about when I've done this in the past. And it's probably at your second PHP job. Your first one, I bet you didn't have enough authority or even like confidence in your skills to go and come up with this problem. But you got your second one, and someone's like, "Hey, this guy knows what he's doing. Let's give him a project. Let's just see how this goes." And so you're making decisions. You're building architecture. It might be a little bit in over your head, but you're pounding through it, right? You sit down at your keyboard, start typing. So at this point in your PHP life, MySQL is your everything. You've got a file system that's perfectly good. There's all these other pieces of software out here that do IPC. IPC, inter-process communication, basically job queues, right? Something comes in, some other process needs to deal with it. So for some reason, PHP is always just taught with MySQL. That's like, I'm not looking for a PHP developer, I'm looking for a LAMP developer. There's always a database, right? So you're learning how to do PHP stuff, and the first thing you want to do is how do I write to a database? Because that's what you think every piece of data you take in, if you have to store it, it goes into a database. And you know how to make database tables, you have a database tool, you've got PHP MyAdmin open in the second tab. It's super easy to go make another database table and you just start putting stuff in it, right? You know how to do that. It doesn't require any extra software. So it's not a great idea, but it's easy and it works. When you're building out a feature and you've got PHP running on your laptop and everything's great and rows are getting written, and then you've got a separate command line script that you can run, and it comes and it talks to these rows and everything is happy, what's wrong with this? So it'll work on your laptop, and it'll probably work on your laptop forever, because there's not an angry horde of people on the internet hammering on your laptop. But I promise you this will fail in production. I've made this mistake. I've done it even on accident and then wondered why 5 minutes after we deployed the application to production, New Relic has freaked out. People are coming from across the office. "Hey, did you know the site's down?" "No, I didn't, but I do now. Thanks for telling me." A third person, "Hey, did you know the site's down? Leave me alone. I need to fix this." So lots of different reasons, but mainly databases are not job queues. You have locking, you have polling issues, you have I/O query caches. So let's talk about what that actually means. So one of the problems is if you have a job queue and it's got 1 million records in it, things that you do to that job queue implicitly get locks on the table. So if you have lots of processes that are coming in and talking to that table, they may get blocked. And you may end up with all of your connections to MySQL suddenly got blocked. You have data coming in from your website. You do a request, you write something in a database really quickly so you can give that person their HTML back, and let's just call it credit card processing. Credit card processing in itself, I think, is probably an anti-pattern that we can talk for an hour about. So you put it in the transaction, you put it in the database, but now you're really popular and you have millions of transactions going to the database, or thousands or even hundreds. So let's say you come along on the back end and you say, okay, I need to process these credit card transactions, and let's say that takes 1 second to process a credit card transaction, but you don't want to wait for the user. You want to give them their HTML back and their thank you page. So you go process a transaction, and then you suddenly get popular, and now you're processing 10 transactions or 100 transactions, and they all take a second. Well, now something happens, and now they take 5 seconds instead of 1 second, or they take 10 seconds, or your credit card guy's down. So you have these processes that are sitting there, and they've got locks on this database table. Now you have a real problem, because at some point where you have locking, it's really hard to figure out what the hell MySQL is doing at this point. You've got website trying to write to the table, you have processes trying to read from the table. One of them is going to get blocked, because even MySQL 5 latest, at some point you'll have enough things reading and writing to this table that somebody's not going to get access to the rows until the other things are done, right? And that defeats the entire purpose of this, because now you're back into a serial process again. You've got things that are waiting. So what else could you do? So you might have to pull this, right? You might have a back-end process that's looking at this database table, select count star from things to do, limit 1, right? Just, do I have any work to do, right? Website's putting stuff in, you've got another thing that checks every 30 seconds to see if there's anything in the table, cron job, let's say every minute. Every minute it goes and checks to see if there's something in the table that it should do work on, right? So now, not only have you got the website writing, you've got something that's literally slamming a database table. And assume it's not one, right? It's probably lots of them, or you wouldn't need a backend process for this. You've got things that are just sitting here doing queries on your database over and over and over again, really for no reason. MySQL doesn't support notifying a process that a row showed up. Actually, Postgres can do this, SQL Server can do this, but even that is probably not a good idea. Simply just the I/O of it all. Your database is ACID compliant. It's going to try and make your data safe. So writing a bunch of rows to a database table to work on later, your database now, you're taking away I/O capability that your database is using to write profile changes and count how many page views somebody has and all that kind of stuff. You're taking away that I/O and you're using it for backend processes that should be using like probably a different server, different network, something altogether. So you're just wasting I/O that your database can only talk to the disk so much. And it's going to talk to the disk because that's the whole point of a database, is to make sure it's safe on disk. The last thing, specifically MySQL, is very bad about this, is the query cache. So one of the reasons that MySQL and PHP aren't dog slow out of the box is because MySQL has a query cache. If you issue the same query exactly, down to the character, a second time, it comes out of memory. MySQL has already actually gone in, it's saved the hash of the SQL that you wrote, it's got the result in memory, not from the disk, it doesn't have to look at the tables at all. Every time you change one single cell in the database table, the query cache for that table is completely gone. So this really bites you. If you have a table that's called job queue, you probably don't care about the query cache, right? You're not doing awesome, really cleverly crafted selects on this table to render HTML for somebody. But where this bites you is where the doing database IPC has snuck up on you. You haven't set out to write a job queue in a database, but what you've basically done is created a job queue in the database. So let's say you have a user and they're supposed to get a welcome email when their account gets created, okay? So somebody signs up, they put their username, they put their password in, they put in their first and last name, they hit submit. You put a new row in the database for that user, great. They get a thank you page, welcome to my application. You put a has been welcomed column, right? And I'm going to have another process that comes and sends out those welcome emails. So I didn't build a job queue for welcome emails or even email sending, but now I've basically implied that my users table is a job queue. And so that's where you can kind of find yourself in a place where these things snuck up on you. You didn't mean to build a queuing system, but that's what you did. Because now, whatever is coming along and sending these emails to people is going to blow away the query cache on your users table for every other query on that table. Because it's going to come along and it's going to say, select every minute, it's going to say select star from users where has been welcomed equals 0. And then it's going to send their emails and then it's going to issue an update. It's going to issue an update, has been welcomed equals 1 for this user. And as soon as it does that first one, every other query that joins on the users table, every other query that talks directly to the users table, that left joins, you name it, all of those queries are no longer query cached. So your, most popular users queries is joins on users and page views and likes and submitted images and whatever else you might have. That query, which is really expensive, and MySQL cached it for you, you change that users table and it's completely gone. So it's going to have to go back to the hard drive, scan everything, then you're wasting I/O, and then you're back into this whole I/O problem again. You really have to be careful about this because it's so easy to accidentally do this. And so I was looking and I was like, who does this in something I can just find on GitHub? Who started Wikipedia? Wikipedia actually has like an 800-line class dedicated to this. Now, I don't know if they're using it for Wikipedia proper, but it's in MediaWiki, which is basically the source code for Wikipedia. And it's not like they did it on accident. It's like a really, really, really elaborate system for using the database as a job queue. So if you happen to be running MediaWiki internally, you should look and see if you're doing that on accident. Like maybe they're just doing that for you. But it's method upon method and just really, how do I store blobs in my job queue? And basically like the concept of job queuing images in a database. It's not good. So that's database IPC. Let's talk about interfaces. Many people use interfaces regularly in their code. Handful. How many people know what an interface is supposed to be used for? All right. So let's talk in the context of code that you put up on GitHub. No one's going to build an alternate implementation, I promise. Your code could be really good. I bet you don't need an interface. So why do we use them, right? In PHP, there's a couple reasons. Because you could have something that's very generic, and you want people to be able to build alternate implementations, right? I don't care what this thing is, as long as it has a set foo and a get foo and a toString method on it. As long as they pass me something that has one of those, I'm good, right? I can also type hint on those, so I can require that things that implement an interface be passed into me. Totally valid. Not hating on interfaces at all. And type hinting is actually one of the probably more popular uses of it. I mean, because you can't really duck type in PHP besides from checking if all these methods exist. Interfaces are really useful for that. But what you have to remember is, who is the audience? Is this a library that you're really proud of and you put on GitHub and you made it really super fancy object-oriented? Is anyone else actually, first of all, let's talk about, are they going to use it? Maybe, right? If it's just one person and you just wrote it and it's on GitHub and you use it at work and like your coworkers use it, great. Do you think they will actually need to build an alternate implementation of the objects you already have? I bet they won't. I bet you already built the base cases, and that's probably all you need. So there's probably not a reason to extend what you wrote. You might want them for type hinting, right? You might actually, one of the few cases here is where you have data that's coming in from external sources, maybe from a job queue, maybe from a database, and objects get constructed dynamically, and it may be a different kind of object based on what kind of database table it is. This is totally fine. There could be interfaces for that, and it could make total sense. The example I'm going to show you is not quite the same. My point is that, as with all of these, it's a slippery slope. You can have an interface, and I've done this. I did this like a month ago. It started out with 2 methods on it, and I was like, great, interface, 2 methods. I'm going to type in the shit out of this, and it's going to be awesome. And then as I started writing the rest of the implementation, I was like, all right, well, now that technically needs another one. And then it ended up being 6 methods. And at that point, I was like, okay, are these things really that similar that they're actually an interface? Like, it actually, if X implements Y, does it actually implement that? Like, is this actually the right even metaphor for how you should organize the code? So they can start out small, and then they can start to grow. And when they start to grow, the more methods you add to an interface, the less likely it is that somebody will ever want to implement that interface, or actually be able to. It's possible you have so many methods that the alternate implementation can never be so specific as your interface, and you're actually leaking your implementation into your interface. So, offers.com, we don't use our database as a job queue. We have one called Beanstalk. It's wonderful, and the PHP library that pretty much everybody uses to talk to it is called Beanstalk. Beanstalk was PHP 5.2 compatible for ages, and finally they opened up some contributors on it, and everybody sat down and wrote a 5.3 minimum feature branch. So they're like, we're going to namespace it, it's going to be great, we're going to do all this stuff, and then they wrote this interface that has 27 methods on it. I can't imagine what the alternate implementation of a Beanstalk interface is. There's only one, it's defined by the software. There's literally no other way to do this. And not only that, this is 8-point font, by the way. And I had to get rid of all the comments just to be able to fit it on one screen. There's constants in this interface. So, and the constants are like port number, and there's a string constant in there, and like default time to live. Basically, like the constants are actually one of the things I might maybe want to change in an alternate implementation, but now I can't. Where I'm stuck with them, I have to overwrite, put my own constants in. But I mean, the interface here is basically a list of things that Beanstalk knows how to do. And so it seems pretty self-evident that there's only one way to talk to a Beanstalk server. Maybe I'm wrong. If someone knows another way, I'd love to hear it, because I'd like to see your implementation of how this works. So that's the idea that no one will ever be able to use this aside from the original author. And I argue that the original author has no need for it whatsoever. So another one that I overheard people talking about just before the meeting started that I'm calling blind faith, which is, I'm sure it'll be fine. So this is really very generic, but I have some kind of more concrete examples. So failure to check return types. PHP makes this so easy. The core language has mixed return types all over it, right? And this is one of the places, if I had to list, this is the #1 reason why offers.com will ever have a fatal error on it, is failure to check return types. And I would say, of all the times we've ever had the website white screen, which is right, it's a fatal error, but the error reporting is turned off, 95+% of the times. And it's happened, not as much as it used to, but it's happened a lot. And the reason is check your data models. So first of all, a lot of data modeling systems, Doctrine not excluded from this, you have this concept of, well, what happens if there's nothing in the database that's satisfying your query? Maybe it'll return an empty array. Maybe it'll return null. Ours returns an empty array. Maybe it'll return false. PDO itself returns false in some cases instead of a PDO statement. So the problem is you end up, and it sucks because you have to write a lot of extra code for this, but you end up having to if around every single thing that comes back out of your database, because probably the very next thing you want to do when it comes out of your database is call a method on that object. So the object got instantiated based on rows in the database, and the next thing you want to do is call some method on your brand new object. Well, what if it doesn't exist? You can't trust that this thing is going to return you an object. And this, this is a very specific example, and it starts to grow out from there. So aside from just your data model itself, which maybe, if it always returns you an array, and it's just an empty array or it's an array of objects, that's a start, right? Because at least you'll know it's an array, for sure. And you can check, an array, an empty array is Boolean false, and that ends up being pretty useful. If it returns null or an object, that's getting to be more dangerous. But check your database. So one of the main reasons why we ended up with lots of places where we had to check the return types and not checking the return types resulted in a fatal error was because we assumed there was going to be rows in the database that backed that query, and they somehow disappeared. Be it they never got published from our content management system, or our users of our content management system had found new and novel ways to enter data in a way that no one had ever thought about. So, especially with databases, this is really a problem. There's probably offers.com has 3/4 or millions of lines of useful code, and I would bet there's 200 to 300 places where this is still a problem. It just has never manifested itself. We assume if we have a page for a company on the website that it will have offers. I'm pretty sure that's still a problem to this day. Because why would you put a page up if you didn't actually enter any content through the page? So this is resulting in an e-fatal, right? And that's one of the worst kind of errors. You can't do much about that at that point. If you have your web server set up properly, your users are just going to get either a white screen, or they're going to get like half of some HTML, and maybe it'll like stop in the middle of a attribute on a link tag or something, and who the hell knows what they're actually going to see. They're not really recoverable. You need fairly expensive monitoring software to get a good representation of what your fatal errors are. But the problem is that you just assumed that the environment that you built the thing in is the environment that it's going to run in. And this concept just applies to everything, but I wanted to show you one of the ones that I'm personally guilty of, and we built websites like this and we made millions of dollars on it, but Jesus, it's a bad idea. So, index.php !page. Import, so you can see what's going to happen here, right? It's going to, very easily I can say, and important variable equals 2, and everything else from that is suspect at best. When I learned PHP, I was working for the University of Texas Department for Geophysics, and every now and then I remember that we did stuff like this, and I would go and check, and those pages are still there, and they're still happily serving away. And I'm like, man, I can SQL inject so much stuff on this page. But when you say extract is one of those things, like, why does PHP let you do this? Why? Because it's actually kind of useful in some cases. But it's super dangerous, right? Like, this was like when I sat down and I was learning, how do I get at these things, and how does PHP work, and how do I get variables from the URL, and I didn't have a ton of experience doing web programming at that point. I had done some classic ASP. When I got my hands on extract, oh my goodness, it was so great. I didn't have to define all these variables; they just showed up. And then I thought, I didn't immediately arrive here. I started with my own arrays, and arrays that came out of the database, things like that. But when I realized that you could extract $_get, I was like, variables are just there. This saves me so much coding. This is terrible, right? So this is exactly this is not even blind faith. This is just blind stupid. I mean, this is trusting someone on the other side of the world that their inputs are going to match your inputs, right? It's just ridiculous. But there are places in PHP where you can do stuff like this because it may be useful in some cases, but it's trusting you to actually think about what you're doing. I'm sure no one's ever done this besides me.
Oh.
Anyone? No? All right. I thought I was hot shit when I was doing that. So the last one that I want to talk about is sequential coupling. So you've probably seen this, and you may have even written it. I remember doing this stuff when I was first learning object-oriented programming. So these are, your objects have to have their methods called in a certain order, right? Now, another way of saying that is your objects are not in a ready state when they get their constructor called, among other things. So it might require setters after constructors, right? So kind of failure to inject dependencies properly. There is an argument that you have setters for all these dependencies that you want to inject, and it's fine. That's a reasonable argument, and it's a pattern people use. But the problem is that you construct an object, and if you haven't read the code and or, especially if it's somebody else's object, read the documentation, who's to say that you'll know all the things that you have to do after you get an instance of this object? Any given instance may or may not be valid. So you're requiring external state management at this point. You're now responsible through no programming contract whatsoever for managing the validity of this object because it requires that you construct it and then call set adapter and then call init. And objects that haven't been initted yet throw some sort of exception. That's totally insane. Because you have a valid method on your object. I mean, surely you've seen these before where there's is this thing currently in a valid state? Does it have all the properties set to make something useful, right? Like, this means that you have to write code every time you have one of these objects. So it's a new object, and then the 3 things you have to do after that to make it in a state where you can use it. And it's not just all about state. I've seen this with poorly written API clients. And it's not really the API client's fault, and maybe it is the API design. Bing's paid search API is pretty bad about this, where the API client is trying to represent state of, and HTTP is stateless, so it's trying to represent the state of these things that you're putting into the system. And so it has it's modeling these API calls, but you have to make the API calls one after the other. And so that's fine in the context of this other system over here that has nothing to do with objects, it's just how their system works. But when you try and model that thing in an object, now the object has this weird dependency that if you don't understand how the system over here works, the object is basically useless to you because you can not only get the object in a weird state, you can actually get the system over here in a weird state because of the way that's implemented. And it's tough. There's some places where you can't do anything about this. But the intent that I think people should do is that after you run the constructor function of an object, if it has one, that object should be ready to go. If that means you have to have 20 parameters, maybe you want to look at a dependency injection container instead. But this is, first of all, nobody likes writing documentation for software. So if you put this code out here in GitHub, people are going to play with this and they're going to hate it because you didn't write a README file. They came across it because it was named really good on packages. And now, they're like, how do I even use this? Like, what order does it come in? There's no comments in here. I thought it was just going to get an instance of this thing and start calling methods, but maybe not. And then they're going to go on to the next guy's thing who has constructors that work. So those are kind of the high-level things that I wanted to share with you guys. There's, if you go look at Wikipedia, actually has a great list of these. That is where I started the research for this at. I think the big thing to underscore is most people don't sit down and immediately arrive at one of these. Usually organically you get there, and then you find yourself with something that is broken through only some fault of your own. It's not immediately broken, but you find out it's not working right or it's not performing well, and you realize that one of these things is to blame for it. One of the things that I don't have in here, but I will, when I post these slides, I'll add it. Engine Yarn has a really great article on all the different ways you might be doing database IPC that you hadn't thought of. And I will add the link to the end of here so y'all can look at that. But that's, there's a bunch of them that I was like, that I even looked at that and I was like, wow, either have done this, maybe currently doing it, or I never even thought of that, but that's a really good point that you're basically locking stuff in the database by doing this. So that's all I've got. If you guys have questions or you want to talk about it, happy to do that. Thanks for listening and being my guinea pigs.